Welcome back. So let's take a look at the Box-and-Whisker plot that you created and I created. Does yours look like mine? I did mine up here in green. This was this year's Box-and-Whisker plot. And there are several things that we can notice. We notice that my whiskers are much longer, that my range is much greater from 0 to 45 compared to this range, which was 10 to 35. My interquartile range, the Q1 to Q3, for last year is long. It's about 11, but for this year it's short. It's only 8. And so I have a couple questions for you. If the but the one thing that is the same is the medians. The medians are still both 24. So the medians are the same. So does that mean that the teams, both teams, performed equally? Did they do as well? You tell me what you think. Did they do as well or did they not do as well? And if they didn't perform the same, how is it that they have the same median? Think about that and write your thoughts on that. So what are some conclusions that we can draw? Well, as I looked at this, I saw that my medians were the same, but the main reason that my medians were the same was because I had a bunch of, if I look at my scores, if my median was 24, I had two 24s already, and I had a 25 and a 27, and then I had this big 45. And so my medians stayed the same because most of my numbers here were very similar to the median. And where I had a really high score of 45, I also had a very low score of 0 to balance it out. Okay? 45 and 0, if I take the mean of that, I'm going to come up with 22.5, which is very close to my median. So with last year, I had more scores in the middle that were around the amount of the median, both above and below it. So I had more scores that were above the median, but not more scores that were below the median as this year. This year, my medians, the quartile ones, were very close. Actually, they were the same at 17. But I didn't have as many scores that were above the median in my in this year's data, and I had more scores that were above the median in last year's data. So the median matters, but it also matters how many scores above and how many scores below. All right? Now, what happens to the data, though, when we remove an outlier? Now, an outlier is an important thing. An outlier are those types of data that are stuck way out on the outskirts. They don't fit in with the rest of the data. They're way out there. And we have some that are way out there in this year's, that are far away from the data. And you might be able to notice what they are. What do you think they are? There's two of them. Well, they're 0 and 45. That's what makes our whiskers so spread out. Now, we can figure out outliers by using a little formula. And here's how you figure out an outlier. You take your IQR, which is your interquartile range, and you multiply it by 1.5. So let's do it for the first one, for last year's. My interquartile range was 11. So if I multiply 11 times 1.5, that's terrible. Let's do this again. 11 times 1.5, I'm going to get 16.5. Okay? Now I take that amount, and if I subtract it from my Q1, so my Q1 is 17. So if I take 17 and I subtract it, subtract 16.5 from it, whatever that score is, whatever that amount is, I shouldn't have any values that are 0.5 or below. So I don't. Notice my lowest score is 10. So I have no outliers. But if I had an outlier down here that was 0.5 or less, that would be an outlier because it's too far away from the quartile quartile 1, all right? And then I do the same thing on the opposite side, except instead of subtracting 16.5, I add it to my Q3. So my Q3 is 28. And when I add 16.5, I get 40, sorry, that's a 44.5. 44.5. And so 44.5 would be, if that score was, if I had a 44.5, it would be too far away, and that would be an outlier. But again, my highest score is right here, so I don't have to worry about outliers for my orange or last year's. Let's try the same thing for our this year's, for the green ones, shall we? Let me get my green marker. So again, the way that I find my outlier is I take my IQR. So my IQR for the green is 8. And I multiply it by 1.5. So I'm going to multiply 8 times 1.5. And I'm going to get 12. So now I have to subtract 12 from my Q1 and add 12 to my Q3. So my Q1 is 25. Nope, is 17. Sorry, my Q1 is 17. So 17 minus 12 is 5. So if I have any scores that are 5 or lower, those are considered outliers. So look on our list here, 0, 7, 17, 17, 18. Yep, 0 is the only one. It's an outlier. So we're going to remove it. Okay? We do the same thing, but we look at our Q3, which is 25, and we add 12 to it instead of subtract. 25 plus 12 is 37, and I look to see, do I have any values that are 37 or higher? And as I look, again, I see that 45 is higher than 37. So I can cross off the 0 and cross off the 45 because those are considered outliers and don't fit well in the data. They're skewing the data too much. They're making the data not look quite right. Okay, so let's go ahead and now create a box and whisker plot using this new data of 7, 17, 17, 18, 24, 24, 24, 25, 27, and not including those outliers. So let's see, we're going to need, I'm going to do it right here, we're going to need a minimum. I'm going to say N for now. We're going to need a minimum. And our minimum now is 7. And our maximum is 27. What's our range? 20. And our median? Well, our median I think is still the same. It's still 24, right? But what's our Q1? Now we need to find the middle between the 7 and the 24, right? So I'm going to go from here. So I'm going to go from here, take those two, take this one and this one, this one and this one, and I need to find what's in the middle, and it's 17. Between 17 and 17 is 17. So Q1 is 17. And then I do the same thing over here. If 24 is our median, now I'm going to find the median between 24 and 27, and we're going to go from here to here and here to here, and we need to find what's in between 24 and 24.5, or 24 and 25, and that's 24.5. Okay? Our interquartile range is the difference between Q1 and Q3, and so 24.5 minus 17 is 7.5. Okay? Now go ahead and create your box and whisker plot down here along the bottom or wherever you have space, and I'll do mine as well. Okay, so here's my box and whisker plot. What happens to the data when we remove outliers? Go ahead and tell me what you think happens. Compare the blue to the green. What happened? Everything got pushed down and to get it closer together, didn't it? It's not as spread out. But we can see now that still everything is shifted lower. Overall, the scores from this year are lower than the scores from last year. The minimum is smaller, the maximum or the minimum is less than the minimum from last year, the maximum is quite a bit less from last year. Even the Q1 is the same, but the Q3 is not. The Q3 is pushed down, and the median is the same. But if you look at the interquartile range, the whole box has been shifted down, hasn't it? It doesn't have as big of a spread. So by removing the outliers, we can see even more clearly how the data really looks. Okay? Now let's talk about percentile ranks, or finding percentiles. If you want to find a percentile, sometimes you hear about this in testing. A student got tested and they're in the 90th percentile, or they're in the 50th percentile. What a percentile means is, where do you rank, or where does the data rank in the entire list? So here I have a list of data, and you may recognize this data. This is the amounts of sugar in cereal. And I want to know, where does the cereal that has 12 grams of sugar per serving rank? Where does it rank? What is its percentile? So here's 12 grams of sugar, right? And I have my whole list, and I have to have it in order. And I need to know, what position is that 12 out of the total amount? So what position is it? So the first thing I have to do is, what is my total number of boxes that were measured? And I had 20. If I count them up, I'll see that there's 20 of them. So out of the 20 different boxes, one of the boxes had 12 grams of sugar. So what position is that in the order? Well, it's the 18th out of 20, isn't it? It's the 18th box out of the list of 20. So if I figure out what that percentage is, 18 out of 20, and I can do it many different ways. I can take 18 and divide by 20, and I'll get the percentage. I can think that, what do I have to do to turn 20 into 100? Because if I can convert it into 100, then that's going to give me my percentages, which is 20 times 5, and I could multiply 5 times 18. I could just know that 18 out of 20, because I do a lot of grading, is 90%. So that means that the 12 is in the 90th percentile, which means that 90% of the boxes of cereal are below the 12, and only 10% are above it. Okay? If I chose a smaller number, like 6, I could figure out what percentile rank the 6 is. So I would take whatever position 6 is, which is 1, 2, 3, 4, 5, 6, 7, 8. I could put 8 over 20. And if I figure out what that percentage is, why don't you figure out what it is? Did you come up with 40%? Probably the quickest and easiest is to use your calculator and do 8 divided by 20. Or, like I said, 20 times 5 is 100, so 8 times 5 is 40. So the 6, the box with 6 grams of sugar, is in the 40th percentile, which means that 40%, or 39%, of the boxes have less sugar than it, and 60% of the boxes have more sugar than it. So that's how you figure out percentiles, all right? And here's a little reminder so that you can remember how to do percentile ranks. They're based on your list of numbers. Take the percentage of numbers above or below your data point, okay? So that's all I have for now. Go ahead and write yourself a key idea. Remember, there's a lot here going on. You have a lot to remember. So think of things that will help you to remember all of these different terms, and what's the most confusing one that you'll need to study and remember. And I'll see you in class.